Welcome to Aviation World.
Let's take a look at how you will interact with the electrical system during normal operations. Some of the items discussed in this section are accomplished by a specific crew member. You can refer to the appropriate manual to determine specific crew duties. If we arrive at an aircraft that has been unpowered for more than 6 hours, it will be necessary to check the voltage of the batteries. Make sure the batteries are off when checking the voltage. Remember, the off lights do not function with no power on the aircraft. Check for greater than 25.5 volts to ensure the batteries have a charge of above 50%. In this example, both batteries pass the test. We would normally select the BAT push buttons to auto, establish external power, or start the APU, and then continue with your pre-flight checks. In this example, one of the batteries does not pass this test. In this case, it would be necessary to do the following. Select the batteries to auto, establish external power for at least 20 minutes. Recheck the batteries in the off position, select the batteries back to auto. We will first select both battery push buttons to auto. We have now done this for you. You will not see a change in the BAT push buttons since auto position is lights out. One of the items that is working now is VHF 1. We could use it to call for external power if necessary. Next, we will establish external power. Here, external power has been plugged into the aircraft. Advance to select external power push button to on. External power is now established and the entire aircraft electrical system is powered. We have selected the electrical page for you. You can see that the battery contactors are closed and the batteries are charging. In this example, the BCL is charging both batteries because the voltages are both below 26.5 volts. Charge the batteries for 20 minutes. While doing so, you can press on with other pre-flight tasks. The APU should not be started during this 20-minute charging period. Starting the APU would drain the batteries even further. Starting the APU would also prevent charging of the batteries for approximately 30 minutes. This is to prevent overheating of the batteries. After 20 minutes, select the battery push buttons back to off and check that the voltage is greater than 25.5. You would then select the battery push buttons back to auto. We have done that for you. During the pre-flight check of the overhead panel, ensure that the guards are down and lights are out on the emergency electrical power panel. During pre-flight of the electrical panel, it is normal for the fault lights on the generator 1 and generator 2 push buttons to be illuminated. Check closely to make sure it is not the off lights you see illuminated in these push buttons. As a general rule of thumb, there should not be any white lights illuminated on the overhead panel during the pre-flight. Any white lights would need further attention or action. All remaining push buttons should be lights out and the guards should be down on both IDG push buttons. Later in the pre-flight, the captain is required to do a second battery check. To do so, the electric page must be displayed. We have done this for you. You would now select the battery push buttons off. Advance to select the battery push buttons off. You now turn each battery on one at a time. When you do so, check the strength of each battery by checking that the battery charge current is below 60 amps and decreasing within 10 seconds. Advance to select BAT 1 to auto and check the amperage for BAT 1 on the electrical page. Battery 1 has passed the test. Advance to select Battery 2 to Auto and check the amperage for Battery 2 on the electrical page. Again, the amperage is less than 60 amps within 10 seconds. Battery 2 has passed the test. If a battery does not pass this test, maintenance assistance is required. Now it's time to start the APU. Let's push the APU master switch. The on light should illuminate. The master switch on light illuminates. After 5 seconds, we can push the APU start push button. Advance to push the APU start push button. When the on light in the start push button illuminates, it does not mean that the APU has started. It simply means that the APU start process is in progress. The APU generator is not yet available with the on light illuminated. This is important to remember. Do not allow the ground crew to pull the external power cord when the APU start is in progress. This would lead to accidentally depowering the electrical system. The avail light is now illuminated and we can transfer to APU power. While it would not be normal to have the electrical page displayed at this time, we have done so for academic reasons. The electrical panel will not indicate if APU power is available. The APU Gen push button simply remains in its lights out on position. The APU Gen box now shows up on the electrical page. Since external power has priority over the APU Gen, external power is still powering the entire system. Do you remember from controls and indicators which push button we have to push to transfer to APU power? If you said deselect external power, you would be correct. This disconnects external power from the system and allows the APU to power the electrical system. Advance to deselect the external power push button on the electrical panel. The APU Gen has now taken over and is powering the entire system. The 2 avail lights are also a clue that the APU is powering the electrical system. Advance to allow ground personnel to pull the external power. Ground personnel has unplugged external power from the aircraft. The external power depiction on the electrical page is removed and the avail in the external power push button extinguishes. We will now start the engines, again reminding you that the electrical page would not normally be displayed at this time. We have now started engine 2. Generator 2 is online and powering the right side of the system. The fault light in generator 2 push button has extinguished. The APU through the left bus tie continues to power the left side. The right bus tie opened automatically to isolate the 2 sources of AC power. Keep in mind that the bus ties are not depicted on the electrical page. We have now started engine 1. Notice the changes on the electrical panel and electrical page. Generator 1 is online and powering the left side of the system. The fault light in generator 1 push button has extinguished. The left bus tie opened automatically. With both bus ties open, the APU is not powering anything. At this point, if you selected bus tie push button off, it would have no effect because they are both already open. Advance to push the APU master switch to shut down the APU. Notice that the APU box and parameters are no longer displayed on the electrical page. However, the white APU Gen indication is permanently displayed. Let's look at some abnormals related to the electrical system. We will begin this section with a simple, straightforward malfunction. A single chime and master caution light alerts you to the fact that IDG-1 is experiencing low oil pressure. We have canceled the master caution light for you. The fault light in the IDG-1 push button illuminates. The electrical page is displayed and indicates IDG1 low pressure. There is also an ecam message on the EWD with only one action step. Advance to select IDG1 push button off. The guard has been raised and the IDG1 push button pushed. The IDG fault light extinguishes, the blue action step is removed from the EWD, and IDG1 is shown as disconnected on the electrical page. The generator 1 fault light is now illuminated. Also notice that Gen 1 is now offline and Gen 2 has picked up the load through the bus ties. You might want to consider starting the APU. For now, just advance to push either clear key on the ecam control panel and display the status page. You're reminded about the APU Gen 1 and galley power. Main galley means that you have shed the main galley, ironic, and in-seat power, but the secondary galley coffee makers are still powered. If all galley power is lost, just galley is displayed on the status page. You would now clear the status page and consult the ecam. Let's look at the loss of AC bus 1. We have already canceled the master caution light for you. The first obvious implication is the loss of both captain's display units and the upper DU. The EWD automatically moves to the lower DU. The red message on the first line informs you that the autopilot is now off. We have cleared the malfunction for you using a clear key. Notice that the loss of AC bus 1 also causes the loss of DC essential bus and, even more important, the loss of AC essential bus, which is listed first. The system automatically reconfigures to allow TR2 through DC bus 2 and DC bat bus to power DC bus 1. A similar reconfiguration will occur if TR1 itself fails, and it would also occur in reverse if TR2 should fail. Basically, the operating TR automatically replaces the failed one and supplies power to the appropriate buses. Now let's get back to the ecam checklist and see how we can restore more buses. Remember that the AC essential bus is unpowered simply because AC bus 1 has failed. The AC bus 1 failure is simply the root cause of our problem. The first action step directs the pilots to select the AC essential feed push button on the electrical panel to alternate. Notice the fault light in that push button is illuminated. Advance to push the AC essential feed push button. The AC essential feed push button allows the pilot to activate an alternate power source for the AC essential bus. This alternate power source is AC bus 2. The AC essential bus then powers the DC essential bus through the essential TR. Notice that the messages relating to the essential buses have been removed. These buses are now powered. This relationship of primary and secondary power sources for the AC essential bus is displayed on the electrical panel with green lines. Notice that the two lines have a different thickness to reflect their priority. Also remember that the AC essential feed push button must be used to transfer power to the AC essential bus. It will not occur automatically. All of the DUs have been restored. At this point, you would normally clear the message and view the system pages affected by this abnormal. Eventually, you would look at the status page. Notice the extensive list of inoperative systems on the right side of the status page. AC Bus 1 is an important bus, and its loss impacts many aircraft components. The good news is that by restoring the AC and DC essential buses, you have restored many systems. If a bus fails, the status page and aircraft manuals provide a comprehensive list of inoperative items. Let's move on to another topic. Here's a quick look at what happens if one of the green monitored circuit breakers should trip. A message indicating the general location of the trip circuit breaker is displayed on the EWD. Additional messages might be displayed depending on the impact of the trip circuit breaker may have on certain systems. Black circuit breakers will not trigger a circuit breaker tripped message, but they might trigger a message associated with the failure of a system. Next, we will discuss the electrical emergency configuration. Discuss is the right word to use here. The nature of this abnormal and its implications are so complex that it is best experienced with an instructor. We will cover significant elements to help you prepare for that training. Assume your really bad day has already started halfway through your flight. Gen 1 has failed, and you have had to shut it down. You have had tried unsuccessfully to start the APU to bring the APU Gen online. Gen 2 is more than capable of handling the electrical load on its own. Unfortunately, it is just not your day, and for some unrelated reason, Gen 2 has just failed. We have canceled the continuous repetitive chime and flashing red master warning lights for you. The most obvious result of this is that both of the FO's EFIS display units, DUs, the lower ecam DU, and the captain's inner DU are all lost. Remaining is the captain's PFD and the EWD. On the emergency electrical power panel, the red fault light is illuminated. This indicates that the rat-driven emergency generator is not yet online. It takes a few seconds, approximately 8, for the rat to extend and come up to speed, and then for the emergency gen to come online. During this short time, the aircraft is powered by the batteries. The rat extends into the airstream and comes up to speed. It powers a hydraulic pump in the blue system, which powers a hydraulic motor that in turn drives the emergency generator. The red fault light is now extinguished and the emergency generator has come online. Notice that the captain's ND is now available and the captain's inner DU has been restored. We will now take a closer look at the message on the EWD, containing all the action steps you will need to handle this situation. The first line reminds you that the autopilot is now off, unavailable. Auto thrust and the flight directors will also be off, unavailable. Common sense would dictate that the captain will most likely be the pilot flying and hand flying the aircraft. We will clear the auto flight ecam message. The primary failure electrical emergency config is now displayed on the top line. Notice the red land ASAP on the right side. We need to divert to the nearest suitable airport. The first action line reminds you that you must maintain a minimum airspeed of 140 knots to ensure the emergency generator provides uninterrupted power. If the rat had not extended properly or the emergency generator failed to come online, the fault light remains illuminated on the emergency electrical power panel. An additional action step would be displayed on the EWD, directing you to push the rat and emergency gen man on push button in attempt to bring the emergency generator online. The next ecam steps directs the pilots to attempt to reset each generator by selecting each generator push button off, then back on. We will assume that the generator reset has been unsuccessful. The next action step directs you to use the bus tie push button to split the system and then attempt to reset each generator again. This is done in the hope that one generator, now isolated from a possible short, might be regained. A word of caution about the bus tie push button. It should be used only when directed by the ecam. If selected off, the APU gen and external power are not able to power the system. It also prevents one engine-driven generator from powering the entire system should the other engine-driven generator fail. Assume these steps were taken and again failed to bring the generators back online. The remaining steps provide actions and information related to the various other aircraft systems impacted by this abnormal. Note on the right side that ecam messages relating to navigation, flight controls, and autoflight are currently buried and waiting for you once you clear the emergency config checklist. You also see that if time permits, the pressure, hydraulic, and fuel pages should be reviewed to assess the impact on these systems. These are secondary systems affected by the primary failure. When all the ecam messages are cleared, you will see an even longer list of systems pages that should be reviewed. With only one ecam screen available, these systems pages will not appear automatically with the use of the clear push button as with other abnormals. To see a systems page, it will be necessary to push and hold the appropriate key on the ecam control panel. Even though the electrical page is not listed, we'll take some academic license and use that procedure to look at how the electrical system is configured at this point. Advance to push and hold the electrical key on the ecam control panel. The emergency generator is now powering the essential AC bus directly. Through the essential TR, the emergency gen is also powering the DC essential bus. All other buses are unpowered. If the emergency gen is operating, these essential buses are always isolated from the rest of the system. Some people refer to this area of the electrical page as the rat's nest. In this configuration, you should still have all the components essential for a safe recovery. A partial list of items available and how some systems are affected includes VHF1 and HF1 are available, the flight controls are in alternate law, normal gear extension is available, alternate braking is active, normal engine operation with fire protection and continuous engine and ice, FMGC1 is available, the ability to fly in ILS, VOR, or NDB approach is retained. A chart listing the systems powered in the emergency electrical configuration is located in your aircraft manuals. We will look at an example of this shortly. Below 125 knots, the emergency generator will no longer be available. To state the obvious, there will not be enough sufficient airflow for the rat below 125 knots. You will need battery power and the captain's ND will no longer be powered. However, other items such as the PFD and EWD will remain powered until the speed is less than 50 knots. At 50 knots, the AC Essential bus will no longer be powered and all display units go blank. You will still have braking, engine control, and the ability to communicate on VHF1. Nose wheel steering will not be available. You will have an opportunity to experience the electrical emergency configuration later in your training. A list of items available in the emergency electrical configuration and battery power is in your aircraft manuals. You will also notice a difference between battery power in flight versus on the ground. There are also notes at the bottom of the page. The notes provide additional information regarding what is powered in different situations. Additional systems are listed alphabetically on each page of the table. Here are some more systems. And here are some more. It is not necessary to memorize all the items on these tables, but it is good to have a basic understanding of the effects of the emergency electrical and battery power configurations. This completes the abnormal operations section. The electrical page is nearly identical on all aircraft. There are only some minor differences on CRT-equipped aircraft. This includes items such as a relocated galley shed indication, slightly different emergency generator, and essential TR depiction.
Please visit our website www.part66easa.com for the Part 66 exam preparation. All latest study material, sample question papers, online test series, ebooks are available for free. Thank you for watching this video.